Hey guys, welcome back to General Chemistry. In the last video, we introduced this idea of stoichiometry. So using the numerical relationships between the coefficients to change our units. And then the new kind of wrinkle that we added in was the units that we're changing are maybe from a reactant to another reactant or a reactant to a product. So the units are changing across the chemical equation. Now we're going to ramp up that idea a little bit more. So the last example, I just did kind of a mole to mole example. But typically when we're in the chemistry lab, we're not dealing with units of moles. We have things that measure in like grams, right? So that's the next thing we're going to talk about is how do we get from grams and then to moles and moles and then maybe back to grams. So here's kind of our general map to solve these problems. So quite often the problems are going to be given to us in the unit of grams of a certain substance. We're then going to use the molar mass or molecular mass to get from grams of a substance to moles of a substance. So that's review from back in chapter, I think, 1 or 2. This piece down at the bottom is the new piece that we learned in this chapter. So changing the units from moles of substance A to moles of substance B. So this is our example of going from like eggs to pancakes or flour to pancakes. That was the new step that we just introduced in the previous video. And here to go from moles of A to moles of B, we're going to use the balanced chemical equation. We're going to use that ratio of coefficients. And then lastly, most of these problems are not going to be answered in the unit of moles. These problems are going to be answered in the unit of grams. So then now that we are in substance B, we need to then use the molecular mass of substance B to get back to the unit of grams. I highly recommend that you guys have some sort of general roadmap in front of you as you're working these problems. Excuse me, it could be this roadmap. You could use my roadmap, or you could write one that makes more sense to you, something that you come up with. But I highly recommend that you have it in front of you to help you with guiding you through these problems. So let's dive into an example. Let's look at a full-blown example. So here's the example that we're going to work out. I recommend that maybe you pause the video and write down this problem, because I'm going to be flipping kind of back and forth pretty quickly to work the example. All right, so here's the question. How many grams of glucose can be synthesized from 58.5 grams of carbon dioxide? Okay. So let's first kind of figure out what this problem is asking us to do. So it's giving us a measurement in grams. So it's giving us grams of carbon dioxide. And I see carbon dioxide is over here as my reactant. And it's ultimately asking how many grams of glucose. Well, glucose is this molecule right here, the C6H12O6. So it's going to ask how many grams of glucose can we make? So if I click back to that roadmap that I introduced on the previous slide, what our map is going to look like, so if I change this to be applicable to our problem, we're going to start with grams of carbon dioxide. So that's what it gave us. It gave us grams of carbon dioxide. So the first step would be then to go to moles of carbon dioxide. That's going to be step 1. And then if we look back at the problem, we start with carbon dioxide, but it ultimately wants to know about, glucose. So this new step that we introduced in this chapter, we're going to go from moles of carbon dioxide and we're going to get to moles of our glucose. Okay. And we're going to use the balanced chemical equation. So this step right here is that new step that we introduced. And then the problem is asking us for grams of glucose. So the last step, once we're in moles of glucose, the last step would then be to transition up to grams of glucose. So that's going to be our process to get through this problem. We're going to go from grams to moles, moles to moles, and then moles back to grams. So remember, these stoichiometry problems are just really glorified unit conversion problems. So what's the first thing that we do for every unit conversion problem that ever existed? We write down the information that's given. So the information that it gave us is 58.5 grams of carbon dioxide. So that's what I'm going to write down. Okay. All right, I'm going to draw my train tracks. I'm going to write grams of carbon dioxide down here. And then my first destination, if we go back to that map, my first destination is grams to moles. So moles is going to go on the top. Okay. So what numbers do we put in here? Well, we're going to use the molecular mass or the molar mass. So just as a reminder, molar mass is as follows. 1 mole equals X number of grams. So in this case, 1 mole of carbon dioxide, and we can determine grams of carbon dioxide. And to do that, we have to look at the molar mass on the periodic table. So we go to the periodic table, and we see that carbon is 12.001 grams per mole. Oxygen is 15.999, and there are 2 oxygens. So I add all of these numbers together, and I get 12.011 plus 15.999 plus 15.999, and I get 44.009. So 1 mole of carbon dioxide weighs 44.009 grams, and that's what's going to go into my train tracks. If this is a little shaky, remember this is a review from chapter 2, so go back and catch up on that. All right, so the number 1 is with mole. 44.009 is with carbon dioxide, and I multiply across the top, divide by the bottom. So I've got 58.5 times 1 divided by 44.009, and I get 1.33 moles of CO2. So my grams cancel, we're left with the unit of moles. All right, so let's go check back in on our map. Let's see where we're at here. So we just went from grams to moles, so now we're down here in this gray box. The next step is going to be to go from moles of substance A, which is our carbon dioxide, to moles of substance B, which is our glucose. Okay, and we're going to set up a train track to do that. All right, so I'm going to take the answer from the first step, and I'm just going to start a new train track. 1.33 moles of carbon dioxide. I do my train tracks, and with little to no thought, I'm going to put moles of carbon dioxide at the bottom, because that's what's going to cancel. What was my destination from this step again? Well, it was moles of glucose. Okay. So again, we're just using dimensional analysis. We're letting the units guide our problem. So where do we get these numbers to go into this portion of our train track? Well, this is the new step. This is where we go to the balanced chemical equation, and we use the coefficients that are in front of each of these molecules. So let's start over here with carbon dioxide. For carbon dioxide, the number 6 is attached to carbon dioxide. So the number 6 is going to stick with carbon dioxide, so that's going to go on the bottom. And if I look over here at glucose, there's no coefficient. Remember in chemistry where there's not a number, the number 1 is implied. So there's a coefficient of 1 with glucose, so the number 1 is going to stay with glucose. Okay. And then just like before, we multiply across the top and divide by the bottom. So 1.33 times 1 divided by 6, and we get 0.222, call it 2. And now our moles of carbon dioxide cancel, and this unit is moles of glucose. Okay. That's the only new piece here. That's the only new step. Everything else is just review. All right, so let's go check back in with our map here. All right, we are now over here. We are in moles of our glucose, but if I read my problem again, it's not asking for moles of glucose. It's asking for grams of glucose. So now we kind of need to go the opposite direction and go from moles to grams. All right, so we take the answer from our previous step, and we're going to start a new train track. So 0.222 moles of glucose. Moles of glucose is going to go on the bottom, because that's what I'm trying to get rid of. And they'll cancel. And my destination is going to be grams of glucose. So we're going to do the same process that we did over here for molar mass, but now we're going to do it for our glucose because that's the molecule that we're dealing with. So for glucose, we've got carbon, hydrogen, and oxygen. So look at the periodic table, and carbon is 12.011, and I'm going to multiply that by 6 because there's 6 of them. Then hydrogen is 1.008. I'm going to multiply that by 12 because there's 12 of them. And oxygen is 15.999. Multiply that by 6 because there's 6 of them. Okay. All right, so I'm going to do that and then clean it up. So 12.011 times 6. 72.06, 1.008 times 12, and we get 12.009, and 15.999 times 6, we get 95.9. So add these all together, 72.06 plus 12.09 plus, we'll call it 95.99, and we get the molar mass for glucose is 180.14 grams per mole. Or another way to state that is there's 180.14 grams in 1 mole of glucose. So we multiply across the top and divide by the bottom. So 0.222 times 180.14 divided by 1. And we get 39.9 grams of glucose. Okay. And that's our answer. That's what it's asking us for. So it says how many grams of glucose, and we were able to answer in grams of glucose. So that is our stoichiometry problem. Have your map, know where you are on the map, and then just continue to let the units guide your problem. I hope you guys found this helpful.